In this video, we are going to learn that the cases when object is placed in front of the concave mirror and convex mirror and as well as plane mirror. So, in the first case, if you see here, the place a mirror, okay, and then mark the focus point of that mirror. So here, the radius of curvature of the mirror is marked 150 centimeters. It means focal length is at 75 centimeters. So focal length is equal to half of the radius, that equal to 150 upon 2, that equal to 75 centimeters. You can measure with the help of scale also here. So from here, mark the 75 centimeters, you can see. So 10, 20, 30, 40, 50, 60, 70, and 5. So it is 75 centimeters. It means simply we can say that half of the radius is focal length. At the same time, now you just place this point exactly at 150 centimeters so that this point is nothing but center of curvature. Okay, this point is nothing but center of curvature. So from here onwards, from here to the focal length, the distance is also equal to 75 centimeters. Okay, now remove the scale and then keep an object at any distance behind the center of curvature. Okay, so this is the object and this is object height. You can place instead of arrow mark any other things also, like pencil also you can keep here. So this is the pencil. We can adjust the pencil here. So better to understand, let me keep the arrow mark. Now pass the light rays so that we can see that the image formed and the position of the image here. So we know there are four rules. Out of four rules, you can take any two or three rules. It's just to see here, the light rays which is coming parallel to principal axis always gets reflect through focus. And the light rays which is coming through focus is getting reflect parallel to principal axis. And the light rays which is incident at a pole, it is making the same angle like as incident ray and below the principal axis. And if you change the position of the object, the position of image also gets changed. Is it right? And if you change the position of size of the object, the image position, image size also is changing here. Okay, you can see here that clearly as the object is moving from far point to towards the mirror, the image is changing its position, moving away from the mirror. You can see here. Okay, so this is the first case when object is beyond center of curvature. It means behind the center of curvature at any distance. So image formed is below the principal axis. Okay, below the principal axis, it means inverted, and it is in between focus and pole, focus and center of curvature. So marked as C here. Okay, at the same time, image is smaller than the object. Object size is larger and image size is smaller. So it is diminished and it is formed by actual intersection of light rays. So this is a real image. So what are the properties of image when object is placed beyond center of curvature? Inverted, diminished, and real. So these are the properties of image and image found between C and F. Image found between C and F. F is capital here, focal point. Is it clear? Now change the position of the object. Slowly move this object at the center of curvature. Okay. You can see here, object is placed at center of curvature. Image is also formed at center of curvature only. And you can use these three rays. When light rays passes parallel to principal axis, gets reflect through focus. When light rays passes through focus, gets reflect parallel to principal axis. Another light rays is when light rays incident at pole and it is reflect back along this below the principal axis by making the same angle like as incident ray here. Okay, so the point of intersection is here. So here we'll get the image. The properties of image are it is formed at formed at C. Okay. The properties, first property is below the principal axis. It is inverted. And it is same in size like as object. So object size and its image size are equal. So same size. And it is also real image because the image is formed by actual intersection of light rays. So it is a real image. Properties of image are real, inverted, and same size. You can see that the previously the object is behind the principal center of curvature, then the image formed is between C and F. Now the image position is changed as the object position is moved towards the center of curvature. Image is moved away from the mirror. Is it right? Now slowly change the position of the object. As you can see that object is between C and F, image is formed beyond C. Is it right? Beyond C, you can see that how the light rays are passing and then image is formed here. So properties of image are, it is below the principal axis. It means inverted. Okay. And it is a real image. And if you notice here, the object size is smaller than the image. So image is magnified or enlarged. Okay. These are the properties of image. And now case 4. What is our first case here? Case 1 is object is beyond center of curvature. Case 2 is when object is at center of curvature. Case 3 is when object is between center of curvature and focus. And case 4 is when object is at focus. When object is at focus, the light rays are not intersecting at any point behind the mirror and as well as in front of the mirror. The light rays are moving parallel to each other. So simply we'll say that image not forms. Image not forms. Or another point we can say that image formed at infinity. Okay, at infinity. What type of image and what are the properties of image? So actually image will not form, but the properties if they ask to write, simply write it is in front of the mirror, image formed in front of the mirror at infinity, real, inverted, highly magnified. Highly magnified at infinity. At infinity. Okay. Now these are the properties of image when object is placed at focus. Now change the position of the object as the object is moving towards the center, towards the mirror. It means between focus and pole. So you can see here the as object is moving towards the mirror. The image is not forming in front of the mirror now. Image is formed behind the mirror by extending the light rays. You can see this is the object which is placed between focus and this point is nothing but pole. So image is formed by extending the light rays. That type of image is virtual image and the image is formed above the principal axis. So it is upright, virtual and erect and it is magnified. Is it right? So these are the properties of image when object is placed in front of the concave mirror at different positions. Okay. We'll continue this video for the convex lens in the next session.